Welcome back to Geometry, Chapter 5, Section 6 in this book. Today we're going to talk about indirect proof and inequalities in two triangles. So we've learned several kinds of proof. We learned the two-column proof, we learned the paragraph proof, and we learned the flowchart proof, the flow one. So this is another one, and this is my least favorite. But remember this, there's the logic part of geometry and this is it. And the indirect proof, you assume the opposite to prove what you want to prove. So, for example, I would say, I am Angelina Jolie. Therefore, I have millions of dollars in the bank and can buy whatever I want. But then I go look in the bank and there are not millions of dollars and I cannot buy whatever I want. So therefore I am not Angelina Jolie. That's an indirect proof. Now let's apply one to geometry. You are given triangle ABC. We're going to prove ABC does not have more than one obtuse angle. Remember, triangles can't have more than one obtuse angle. So I'm going to read you the indirect proof and see, and you read along in your book. It's on page 302. Okay, begin by assuming that ABC does have more than one obtuse angle. So we're going to say that angle A is greater than 90 and angle B is greater than 90. So A plus B is greater than 180. You know, however, that the sum of the measures of all three angles of a triangle is 180. So measure A plus B plus C is 180 according to the triangle sum theorem. And the measure of A plus B is equal to 180 minus the angle C by the subtraction property of equality. So you can assume that this is not correct. We could put it back in and it would show that 0 is greater than the measure of angle C, and it can't be. A measurement like that cannot be less than 0. Angles, degrees, if it's an angle, it can't be less than, it can't be 0. The last statement is not possible. Angle measures in triangles cannot be negative. So you can conclude that the original assumption must be false. That is, ABC cannot have more than one obtuse angle. So take a look at that problem in your book, read that idea, but really that's all this class does with that. It just shows you the idea, shows it here, you're never going to have to write one. There it is. You just need to know it exists. Okay, now on to something more fun. The hinge theorem. Remember I told you that the angle across from a side controls how big it is, like a hinge. My hand's acting like a hinge. So we actually have one called the hinge theorem. Okay, so here I have two triangles. They have two congruent sides. Are they congruent? No, not, because these two angles are not the same. The hinge theorem. If two sides of one triangle are congruent to two sides of another, and the included angle of one is less than the other, then the third side is less than the other. Let me translate. This one's 80, this one's 100. So that means this side is smaller than that side because that number is less than that number. So we know these two triangles are not congruent because we know this third side is not the same because of that hinge. So therefore, just showing that two sides of a triangle are congruent is not enough to prove that the two triangles are congruent. The converse is also true. If we didn't know the angles, but we knew this side was longer than that one, we would know that this angle is bigger than that one. That's what the converse is. All right, so let's look at two triangles. They have congruent sides. This side is 12. This angle's 36 and that angle's 80. What must x be? Well, x must be greater than 12 because 80 is more than 36. This could be an easy problem on a standardized test. It would say it'd have this situation and then you could have 4 different choices for x and you would pick the one that's bigger than 12. Not equal to, not less. And not, you can't tell from the problem. All right, here's a word problem. You and your friends friend started off at the airport. You flew 120 miles this way and then turned and flew 70 miles that way. Your friend went 120 miles this way and then turned and went 70 miles that way. Who is farther away, or are you the same away? What do you think? It's tempting to think, well, these two are the same. We both went the same distance, 120 plus 70. We must be the same away. But you'd be wrong because of this. This angle's 150, that angle's 140, so this side is bigger because 150 is bigger than 140, so you are further away from the airport than your friend. That's the kind of word problem I like. Very logical. All right, so that's it for Chapter 5. Come back and we'll learn Chapter 6. Math is great.